Today's lesson is Basic Firefighting. This course is designed to cater for the college students of the maritime schools, seafarers, firefighters, and senior high school of the Department of Education taking up the fire hazard topic. The basic firefighting topic is divided into 4 parts. Part 1, definition of fire, 3 ways of heat transfer, fire elements, the fire triangle, and fire tetrahedron. Part 2, 4 conditions for the fire to exist, classes of fires, types of fire extinguishers, and how to stop a fire. Part 3, phases and causes of fire, and Part 4, precautionary measures and proper procedure in addressing a fire incident. In this series, we will be going to discuss the Part 1 of the basic firefighting, definition of fire, 3 ways of heat transfer, fire elements, fire triangle, and fire tetrahedron. Now, before we proceed further, let me ask these questions. Why is it very important to discuss fire? What is fire and how it is developed? What are the causes of fire? How can we be able to best avoid a blazing inferno, a conflagration that could destroy the environment or our property or injure or take away our loved ones or even us? Now, let us proceed. Fire is a process involving rapid, I say again, rapid oxidation at elevated temperatures accompanied by the evolution of heated gaseous products combustion and the emission of visible and invisible radiation. Oxidation occurs all around us in the form of rust on metal surfaces and in our bodies by metabolizing the food we eat. However, the key word that sets combustion apart from other forms of oxidation is the word rapid. The combustion process is usually associated with the oxidation of a fuel in the presence of oxygen, with the emission of heat and light. Oxidation in the strict chemical sense means the loss of electrons. For an oxidation reaction to occur, a reducing agent, the fuel, and an oxidizing agent, usually oxygen, must be present. As heat is added, the ignition source, the fuel molecules and oxygen molecules gain energy and become active. This molecular energy is transferred to other fuel and oxygen molecules, which creates a chain reaction. A reaction takes place where the fuel loses electrons and the oxygen gains electrons. This exothermic electron transfer emits heat and or light. There are 3 ways to transfer heat: convection, conduction, radiation. Convection, the movement caused within a fluid by the tendency of hotter and therefore less dense material to rise and colder, denser material to sink under the influence of gravity, which consequently results in transfer of heat. Take the case of water being heated in a pot. The hot, less dense water tends to go up, while the cold, dense water tends to go down. The cycle continues until the whole water content in a pot is evenly hot. Convection also occurs in the oceans, and this is one of the reasons why there are ocean currents around the world. Conduction, the process by which heat or electricity is directly transmitted through the material of a substance when there is a difference of temperature or of electrical potential between adjoining regions, without movement of the material. Take the case of a burning piece of wood. When a non-flaming wood is put close enough to the burning wood, the result would be that the non-flaming wood catches fire by its closeness to the burning wood and both having difference in temperature. Radiation. In physics, it is the emission of energy as electromagnetic waves or as moving subatomic particles, especially high-energy particles, which cause ionization. Take the case of a microwave oven. Radiation from this equipment enables the food to be cooked or reheated. The sun also emits radiation that makes the surface of Earth hot. Of the three heat transfers, conduction and radiation are normally the culprits of why there is a fire in our community. Elements of fire are fuel, heat, oxygen, chain reaction. These four elements are a combination to ignite and sustain a fire. Removing fuel or heat or oxygen, the chain reaction stops and the fire is extinguished. Fuel is any combustible material which, when heated, reacts chemically with oxygen and produces fire. This can be papers, clothes, woods, gasoline to run a car, a coal to run a power plant, etc., etc. Heat in physics seen as a form of energy arising from the random motion of the molecules of bodies, which may be transferred by conduction, convection, or radiation. It is responsible for the initial ignition of fire and the spread of it. Fire is spread by preheating adjacent fuel and warming surrounding air. Sources of heat enough to cause a fire: sun, spark and friction, and we can also consider volcanic eruption. Now, let us discuss one by one. Source of heat enough to cause a fire from the sun. Sun's rays that could result to hot surfaces. Or sun's rays concentration from the magnifying glass. Sources of heat enough to cause a fire from spark and friction. Spark plug device from the car. This is used for firing the explosive mixture in an internal combustion engine so that the car would run. Spark from welding, when close to combustible materials or flammable vapor. Friction from the match. Rubbing of two objects against each other as in the primitive way of starting a fire. Grinding machine. Cutting or sharpening the metal when close to combustible materials or flammable vapor. Source of heat enough to cause a fire from the volcanic eruption. Hot magma in the form of lava spewing out from the volcano, heating and burning houses, other structures, and living things along its path. The heat from the lava originally comes from the heat of the Earth's core. Oxygen, a colorless, odorless, and tasteless gas. Oxygen forms approximately 21% of Earth's atmosphere. Oxygen forms compounds by reaction with practically any other element, as well as by reactions that displace elements from their combination with each other. In many cases, these processes are accompanied by the evolution of heat and light, and in such cases are called combustions. Chain reaction, a chemical reaction or other process in which the products themselves promote or spread the reaction, which under certain conditions may accelerate dramatically. It is a series of events, each of which cause or influence its succeeding events. Take the case of a gasoline fire in an open tank. The first thing that the fire will burn at the start is initially the available vapor, which is present on the surface of gasoline, and it is always a surface fire at the ignition phase until decay. The burning flammable vapor from the fire produces heat, which releases and ignites more vapor. The additional vapor burns to produce more heat, which releases and ignites more vapor. The additional vapor again burns to produce more heat, which releases and ignites more vapor until the tank is empty. Once the fire starts to play, the chain reaction is always on the look for further combustion and the fire tetrahedron is formed. Fire triangle, a graphical representation of the three elements of fire, namely fuel, heat, and oxygen. Fire tetrahedron, a triangular pyramid having four plane triangular faces, illustrating how heat, fuel, and oxygen intersect together with a chain reaction to support and sustain a fire. The fire triangle is a simple illustration of the three requirements for the existence of fire. However, it does not explain the nature of fire. It does not include the chain reaction that result from chemical reactions among fuel, heat, and oxygen. The basic difference between the fire triangle and the fire tetrahedron are: the fire tetrahedron illustrates how fire is supported and sustained through the chain reaction. The chain reaction keeps the three phases from falling apart. Many years have come and we are used to understanding the fire by the composition of fuel, heat, and oxygen, forming what is known as the fire triangle. Further fire research, however, led to the discovery of the chain reaction as a component of heat. The fire triangle then was changed to a fire tetrahedron to reflect this fourth element. To summarize, the three ways of heat transfer are convection, conduction, and radiation. Of the three, conduction and radiation are normally the medium to cause a fire in a community. Heat sources enough to cause a fire are from the sun, volcanic eruption, spark, and friction. The elements of fire are fuel, heat, oxygen, and chain reaction. The presence of the three elements plus the chain reaction is the component of fire. Removing one of the three elements, the chain reaction stops and the fire is extinguished. The fire triangle was changed to a fire tetrahedron to reflect the fourth element, the chain reaction. That's it for now. This is the end of the part 1 of this series. For any comments, questions, clarifications, and suggestions, you may write it at the comment section and I should be very happy to reply. Watch out for the next lesson, part 2 of the fire hazard. Before I close it, always remember that prevention is better than cure, and apply this also in the case of fire. This is your companion for learning. When see to end, have a joyful, peaceful, healthy, and fruitful day.